All right, welcome to Nested Loops. We're doing badass, making users awesome, and I believe we're doing. Don, tell me what we're doing again. I forgot. I had
It's perceptual exposure.
yes, science of badass perceptual exposure. So I'll turn it over to Don, and let's go.
Okay, this is the second part of how experts become experts. And we're going to cover perceptual exposure. So this basically is talking about how experts became experts by being around better, meaning being around better people or better information, just repetition of exposure to things, basically. So one conception we have is that when we think about someone that became a pro musician, for example, because his parents were pro musicians, he obviously inherited his talent. But what's actually true is that because his parents were pro musicians, he was surrounded by experts from an early age. So the main attribute of those that became experts that we're covering is that they were exposed to high quantity, high quality examples of expertise. So the more you watch or listen to expert examples, the better you can become. And the less exposure you have to experts or results of expert work, the less likely you are to develop expert skills. Which makes sense if you, even if you're practicing your skills, if you're not around other people that are better than you, you're probably not gonna keep improving in the same way.
Yes. Just a side note, and this is why I have study group. I want to raise our level, and I realize if you spend all your time going to like Agile comps and Ruby comps, you just hang out with guys that are all into this stuff. So, all right, go ahead.
True. And so you might say, if that were true, I'd be a genius musician by now. Have you seen my iTunes playlist? And since they're mentioning iTunes, you can tell this book's a little old, I guess. But the point that they're making is that simply being exposed to examples of expertise doesn't build expertise unless the exposure meets a very specific criteria. So to understand perceptual exposure, we're going to look at some examples. And the most extreme example that we're going to cover is chicken sexing, which is determining the gender of a newborn chick. And it's very difficult, but it's optimal to determine the sex of a chicken as soon as possible, or of a chick, so that you can optimize their feeding. Because I guess there's different feeding strategies for different types based on how they're going to be processed. If they're going to, be chickens that lay eggs, they have a different diet. So in the early 1900s, in Japan, they developed a particular method for chicken sexing, and some experts emerged that could reliably determine a chick's gender. And so then the question was, how do they spread their expert knowledge to the world? How do we make new experts out of old experts? But there's a problem. They didn't know exactly how they were determining. They just knew. Their precise criteria for the near perfect accuracy was not fully or clearly defined. So although they were perceiving subtle clues that could tell them whether it was a male or female, they couldn't explain it. And as a result, chicken sexers couldn't perceive those subtle, unique female chick attributes even when they were instructed by experts. But of course, eventually this knowledge did spread and there were more experts, but how did that happen? How did the existing experts convey something they couldn't explain to new experts? And this happened through trial and error feedback. So the basic idea is that, and this is very extreme, is that student chicken sexers would learn by trial and error by just randomly guessing. They would have a bin on one side, a bin on the other. They would grab a chick and randomly put it in either the male or female bin, and the master that was observing would say yes or no, yes. Just give them some kind of feedback. And over time, their choices became less random just by having somebody that knew the exact answer with 99% accuracy. tell them that they were wrong or right, they started picking up on subtle clues, and eventually, as their choices became less random, they became the experts, um, which is interesting.
This is basically the neural network training method.
Yeah,
It's also how machine learning works, right?
Yep.
exactly. Yeah. So yeah, this is interesting. I didn't know this. That I guess it makes sense that there are things like that, but you think that there'd be some sort of science to it. I guess that's why it was so difficult. It's not something that you could teach. It's really discussing. but okay. I guess this is going to end up being a very short chapter, because most of what we're talking about this whole chapter is this trial and error feedback, and how it extends to perceptual knowledge. So there's another example, which is friend or foe aircraft spotters in World War II in England. They determined that some citizens were able to accurately distinguish between German planes on bombing missions and British planes returning home. But their skill could not be directly explained or taught to new spotters. And this is bad because the British government was really in need of spotters. They had a shortage. But the people that were the best at it couldn't teach new people. But so what they figured out with a little bit of ingenuity was that they could train new spotters by trial and error feedback. A novice would just guess about which side a plane belonged to, and an expert would say yes or no. And eventually, the novices became, like their mentors, vessels of the mysterious, ineffable expertise. So yeah, that's interesting. I guess these two examples don't relate so much to what we do, or maybe it does. I guess maybe like having an eye for something that looks good or bad is maybe a good.
Yeah, since we're going to talk about it briefly, it's like I spend a lot of time trying to coach on debugging, and I think it's a good exercise. And this is related here, but also related to a lot of other stuff I do. There's this saying like, teach to learn, learn to teach. Enforcing yourself, it's kind of related to this thing that people just do and they're good at. When you're forced to examine what you're doing and taking the effort to put it in words, is something you might do instinctually. You're able to pick out the pieces. And so very often I go to lunch with Scott and I explain how I debug something, and I realize there is a lot of just like when I was explaining something, it's a combination of good memory, lots of experience, and knowing how stuff works. And I would talk through and I would go back and step through all this stuff. Well, I did this, but I happen to this. But the key thing is, because I did this 7 years ago, I knew that it was this. But so between knowing this and all this information, and it ended up becoming not quite trial, but that kind of sort of dumping on and showing what wrong, right, and corrections. So
Yeah, I guess the difference to me in that is that you could actually explain why you thought that. Right, is like you had like a list of criteria that you go over. Right.
Yeah, but I think related to this one, it's a lot of. And I see this because I do a lot of teaching in various things. There's one problem with teaching people who don't know is they don't know what they don't know, but also they can't recognize what they don't know. Like this is something I think most people on the team you might be trying to explain some kind of programming thing to someone less experienced, and their question is, how come my less good solution, he doesn't say that, isn't as good as your solution? And you can't explain to them why, but you just know. You have to really think about. It's sort of like I can talk about why I think Ruby is better than JavaScript is programming, but I have like very tangible thing. But sometimes you can't explain. I just like it better, or I know it's better. And of course, these are always things that really make the less experienced person really angry, because the I know or trust me goes, well, why not trust me? But that's a different story. But it's all related to this. I'm okay. I don't want to talk too long on this, but yeah. So
I guess in programming, though, like, and things that we do in general, is usually it's one of two things: either an opinion that you have, like a preference towards a certain editor or a certain language. But if it truly is something better, then you have reasons, I guess. Not just like
yeah, I mean, there are certainly some things that are taste. And actually, and this I think related to some of the other, and some things it's whether it's worth the effort. It's like, yes, so let's say, editor A is better than editor B, but I'd have to take like 7 months of sucking to get as good at editor A as I am at B. Well, then it's not worth it to. You always have to pick and choose those battles. But that's another thing about getting better. But anyway, let's go back to trial and error. So I do think guiding. If you can get guided with enough, it's sort of going back to my whole Ruby analogy. If all you did was go to RubyConf and read like A-list blogger stuff, the stuff you're exposed to kind of shapes your tastes. You start to go, oh, they like this. And sometimes I think it's just rote. Where you see this is what the good guys do, so I just copy and rote, and eventually I start to understand why. Which ultimately, from the educator's perspective, I don't. It's somewhat frustrating, but I think the part here they're talking about, what, this works, so we'll go with it. So yeah, right.
Yeah, I guess.
The problem I have with it is it requires you have an expert to get better then, because you need the expert to guide you.
Yeah, I wonder how the original experts, because when they were talking about this. They said that they developed a particular method, right, in the 1900s. So those original experts came up with a method, but it couldn't, I guess, maybe over time it couldn't be explained. Maybe it got passed down in such a way that it wasn't fully explained, and then it just became kind of intuition.
Yeah, I had that same sort of thing. Well, you said you came up with it, but I don't know what it is. Oh, Rob is saying he's familiar with this. The method looking at
the anus.
Oh, he actually knows the chicken seconds
interesting.
technique. There you go.
But so that would imply then that there's
oh, here you go. Chickens go down the chute.
Okay. So chickens go down a chute. Males are sent to die.
Oh, okay. There you go.
Do they? Right there. I guess you mean for like processing. Like, I guess they would let them grow, but okay. So if you ask an expert to describe how they do chicken sexing, they prefer worse. And overthinking their instincts disrupts their skill. That's interesting. Yeah, so I wonder just kind of what we're talking about. I guess that's trial and error feedback applies the most to machine learning out of what we do and things we look at, right? I feel like a lot of programming things you do learn over time, and you can certainly learn by being more exposed to experts.
Yeah, ultimately that's probably why XP's like pair program all the time. It's
right.
Good, and they intentionally often try to get senior and junior together. So
that makes sense.
This is almost like saying that's why pair programming works better as a mentoring.
Yeah, I wonder if the trial and error feedback there is just to teach a more junior person in pair programming, for example, that they're looking for the right things. I don't know. I still think that they could explain after they've learned why something is better, whereas in this case, they're implying that it couldn't be explained at all.
Well, some things you can even explain. Like, for example, when we code, the simpler code is better. That much, and you can show someone, look, your code was 7 lines, mine's 2. So the guy can go, oh yes, 2 is especially if 2 is actually still clear. You can have like obscure thing, but you can't explain how to get there. So the beginner can say, yes, simpler is better, but I could only come up with the 10-line thing. So that's something where I know I should write simpler code, but how do I do that? Well, if you code enough or you watch enough other guys write the code, part of, I think, in the case of coding is when you see, oh my God, you can do that in 2 lines. Yes. Well, next time around, you'll know the 2-line thing. And you may only by rote know the 2-line, but at least you know. And then down the road, your brain starts to figure, oh, I kind of saw what he did. I can kind of do that. So I can do this other thing, this other 7-line thing in 4 lines now, because I'll do something similar to the 2-line thing. So I guess seeing examples of what is possible, I think, seed. And ultimately, I think that's the part of learning, because you don't know what's possible. Goes back to the guessing. So I guess. And then someone says, oh, guess 11 is the right answer. Oh, cool. So it related to what Rob was saying about cognitive instinct guiding or something rather than. But the educator in me would say, well, if you got enough concepts, like I try to do a lot of my other stuff through concepts, which I find is better because you don't need specific. You understand the concept, eventually you understand how the specifics manifest that concept. But you still need the examples. So I start with the concept. I'm going to give you like 6 examples, which are different manifestations of the concept. And then hopefully you start to go, oh, I kind of get it between the concept and the examples. And I guess the part that I'm saying that's different than trial and error feedback is if you can actually distill the concept, then you give them some guidance that they can independently come up with a solution besides being machine learning trained.
All right. Anybody else have any opinions on any of that stuff?
Nope.
All right. So kind of the core concept behind perceptual knowledge is that your brain learns things that you don't perceive. And it's not magic, it's perceptual knowledge. After you've received enough feedback, your brain starts detecting patterns and underlying structures without your conscious awareness, which is kind of what you're saying, right?
Yeah.
And the more exposure you get, your brain is more able to fine-tune its perception and eventually figures out what really matters. And the whole time your brain was making finer distinctions and sorting signal from noise, even if you couldn't explain how. That's kind of the core concept, I guess, is that when you get that level of understanding and perceiving these things, you can really zone in on the I guess like the important stuff and not listen to the noise. Again, it's like machine learning. Let's see here. So what they found was that experts in all domains develop and use unconscious perceptual knowledge. Their brains know much more than they reveal, or they can be explained. They also call perceptual knowledge expert intuition, and it's the ability to instantly determine things without always being able to articulate how you know them. And developing perceptual knowledge is not necessarily about the people, like the type of person you are. It's about the type of exposure that you get. So not all exposure to experts is going to be good. It has to be a certain type, and more specifically, that whole trial and error feedback type of interaction. They had another really interesting example, which was perceptual learning in flight training. So whenever a pilot's operating a plane, they have a huge panel of instruments, and they're generally able to just glance at those instruments and be able to determine the state of the plane at a given time. And so a study was conducted on both pilots and non-pilots. I believe it was also included pilots, but mainly on non-pilots. And the participants had to view cockpit instruments and determine one of 7 states of the plane, either straight and level, straight climb, straight descent, level turn, climbing turn, descending turn, or an instrument conflict or malfunction, because sometimes instruments will read incorrectly. So within 2 hours, non-pilots were faster and more accurately interpreting the instruments than seasoned pilots with 1,000+ hours of flight experience. And more impressively, the non-pilots received less than 5 minutes of actual instruction. And the structure of the exercise was that they had 2 sessions of 216 trials. And after every set of 24 trials, they would be given feedback. So it wasn't feedback after every single trial. It was after groups of 24. And then they had a separate day that they came back and did the second half. That was kind of the structure of the exercise, I guess. And an additional study was done on navigation using non-pilots. And they also outscored seasoned pilots during this test. And it involved choosing the location of a plane from 3 possible grid locations based only on a 20-second wide-angle video from the cockpit of the plane. And the reason I said that these types of experiments work is that you're given a large set of diverse examples, and your brain begins to detect the things that don't vary. But the important thing is that the set has to be large. If it's too small, then you can start detecting patterns that aren't actually there. So again, it's going to have to be a really large set in a short time, or a long time studying these sets and getting this trial and error feedback like you would if you were working on something for years, I guess. So another thing this exercises have in common is that they create a context that lets the learner's brain discover the pattern instead of trying to explain the pattern to them. There's another example, but most of this chapter was just examples, so I didn't go into detail on this one, was the rule of thirds in photography, where if you're given, that they gave people, or that they just showed an example of photographs that were all different aspect ratios, different sizes, different lighting, different use of color, but they all had the compositional structure of matching the rule of thirds. And one thing that I just briefly talked about here was that you can explain the rule of thirds to somebody and they can kind of use it, but it really just takes more time and more examples of seeing this rule in action before you can really perceive what is a good photograph matching the rule of thirds. So that pattern discovery is often subconscious. And if a learning exercise does fail, then there's some likely causes. You didn't have enough examples, not enough diversity in the examples. Took too long of a gap between the exposure and feedback. So like for the example with the pilots, there was still a gap where they let them do the exercises on their own without getting feedback, but it wasn't too long. Instead of it being, at the end of an entire day of exercises, it was after every 24. And also if an attribute or pattern was too subtle. So I guess if it's something that your brain can't perceive at all, I guess like the chicken sexing thing, or the plane spotting, I guess with those it would take more time maybe, because it's not attributes or patterns that you can easily notice. They're very subtle.
We just lost that message. I'm gonna expand the message thing. I made a comment on the subconscious discovery seems closely related to learning a language in a traditional classroom setting and learning it as a pre-grammar infant or other form immersion. Yes.
Yeah, I agree with that too. Yeah. It's you can be explained something over and over again, but until you have a lot of exposure to it, you're not going to really, it's not going to become automatic, at least. And there, actually, I wish I put this graphic in this page, but there's a kind of a Venn diagram. It says that there's knowledge that you can talk about, facts and procedures, etc. And part of that can be taught to somebody. But if you let someone's brain discover those truths, they get both the knowledge of it and the perceptual knowledge of it. So it's more powerful to discover something than to be just taught it based on rules or facts, procedures, etc.
It's interesting. I do that with my dogs. After saying like sit once, I won't repeat it. I'll wait for them to figure it out because I was told that it will stick much more if they figure it out.
Mm-hmm.
Oh wow.
Yeah.
But by the way, also I think like this applies to a lot of like visual arts or like music or stuff that are like generally they were like apprentice, master apprentice kind of scenarios. Like they were kind of taught this way. Like when I was in the beginning, I was like a designer. And I was always like kind of like surprised, like how people did not see these kind of patterns. And I would say like we used to like do taking care of like a Continental Airlines and Delta Airlines websites, right? So they would do some pages, design some advertisement. They didn't look anything like a Delta advertising or a Continental advertising, and it didn't look right. Same thing with typography. Like typography can look really wrong, but how do you explain when it doesn't look right?
I mean, there are certain like typography, there are like design principles that are pretty standard, but I don't know. It's just weird. Like over time, you develop an eye for these things, right?
Right.
I agree with that. And then even with like UX, like before Hedgeye, I never claimed to be like a UX expert, even though I had worked on web projects. I just thought it was web design. But like through, like all these stakeholder meetings and, just working on so many like web projects and apps, like with Hedgeye, I've like, developed a perception for, what will actually work, like versus, it's just a design element.
Yeah, you gotta work through things. It goes back to a coworker in my other job. He's considered expert in a lot of things, and I was talking to him and I said, he says, you know what I do? When I want to learn something, I get the book, I go through the entire book, and I do all the exercises. And then he goes, and that alone puts me ahead of 96% of everybody. If people even bother to get the book, they glance through it and they don't even, or if they read it, they don't do the exercises. Go through it, do the exercises, because you kind of have to work through them, right? And I always suggest when you're learning Rails, like you grab a good comprehensive Rails book. Say, the book for me was Dave Thomas's original Agile Development with Rails. It's like if you do it first time you go through the book, you're just kind of going through the motions. The second time you go through, you kind of understand what you're doing. By the third time, you can kind of know how to do it without reading the chapter. And that's when you really know how to do it. So working through things seems to be the real success, which I look back and I'm looking at this section here and go, oh, I completely understand why the straight blast gems technique works better than other techniques.
Yeah, but there's no trial and error, right? There's no trial we're discussing here.
Right, but what we are getting at this point is that you have to create the context that helps you discover the pattern. It's really working through it, so you still get the feedback. It is trial and error. Working well. Now, the Rails thing wasn't so much. It is because if you try to duplicate on your own, you fail. You know it's wrong, and you have to go back to the book and see what the right answer was.
I feel like the trial and error, like to computer programming and stuff like that. It's kind of has to do with I feel like this might be a better solution, or in my case, I feel like when it comes to debugging, sometimes I kind of like, I can't remember where I was working recently, that was refreshing a page, and there was something off about the page, how the page loaded, and it wouldn't be something that I could have told you, like how even pop in my head, right? I was like, I think something is getting a 403.
Yeah.
And that's actually what was happening, but like it was just like there was something off about how the page loaded. And it's not something that like, you know, I didn't look for JavaScript error, I didn't look for everything else, but it was because, like, you know, loading a page is something we do all the time, and I cannot tell you what clued me in.
Yeah.
Like there was like,
No, it's definitely that pattern detection thing that they're talking about here.
right.
That definitely is something like the more advanced people have, and it's because of exposure. Because you debug so many things, I guess you subconsciously absorb the patterns of, hey, I kind of know when something is this kind of wrong, which you can't really describe, then it's these kind of things. And a lot of it goes back to when they were talking about you need a wide. If you only debug one kind of problem, that's the only kind of pattern you recognize. If you start seeing lots of different things, you start to build up this kind of perceptual database of stuff.
Yeah, and the brain is very good at recognizing patterns.
Yeah.
On a side note, everybody knows about like side experiments that people are doing with artificial vision, actually how vision and hearing works.
No.
So people they've done like a eye implant, but people are trying to do different things, like different type of devices, augmentation of human capabilities. Where like there's I think this is in a TED talk where people like are doing stuff where they're sending tweets or word representation to the skin, right? Or like a market, like a financial data to a patch of skin, and through trial and error they try to say, oh, this is a good trade or bad trade, right? And they've done a bunch of different times, and they can actually recognize good financial data versus bad financial data through their skin. Just in fact, they send like some kind of like rubbing sensation to the skin, and they can now, and they don't know how.
What?
Right. It's just because they pretty much have gone through enough of the data sets that they can tell what's a good financial transaction versus a bad one. They tried it again with tweets versus a positive tweet versus a negative tweet. They try to do it. What else? The same thing like with the eye. So the eyes, when you send information to the eye, to the nerve, optical nerve, your optical nerve doesn't know how to translate the stuff that you see, right? But it's through a period of time. That's why like a vision when you're first born is very blurry. It's not just that your eyes is not fully developed, or your brain doesn't know how to process the information it's getting, right? And through time, your brain start figuring out how to do it. So they've done an experiment where they send different type of information, not normal stuff, but like infrared or other kind of information to the optical nerve. And people after like a month or so started like seeing, but it's not the same seeing that me and you are doing, but it can still see. And it's just because the brain is like this pattern recognition software. Like whatever you feed it, it'll figure out what the pattern is, even if you cannot, like the skin come out. The thing is crazy.
All right, cool.
All right, so then there's a question of how can we make perceptual exposure experience for our users? Expose users to high quality examples within a compressed time. Not sure exactly how you would go about doing this. It's just talking about users of your product. I know it has some discussion about if it's like a photography website, you don't just you don't need to show why the photographs are good, just show good photographs. Or if it's a coding website, you might show, or a presentation, you might just show examples of good code. You don't necessarily have to go into why they are good. They just need to be high quality examples, and a lot of them. And it specifically says don't expose users to examples of bad. And if you do show them things that are bad, use visual cues to make them feel wrong or bad, such as harsh or ugly filters or overlays, a universal no sign or skull and crossbones, or simply using negative words, bad or wrong. But really the best way to learn how to spot bad is by learning the underlying patterns of good through perceptual exposure.
That's cool.
So I don't know how that really translates to better user experience, but unless it's actually just a teaching website or something, or teaching product.
It would be tough. When I think about products, I go, oh, certainly our product is hard. Let's go back. What was the example we were using? What are kind of wrong? I don't even know what the. I could not read that out loud. Okay, what are these wrong kinds of instructions that inadvertently work against this innate pattern recognition instinct building?
Yeah, let me think. One thing that she said was that if you're, for example, if you want to show like a video that's like an example of how to do something right or some good thing, you wouldn't show an 80-minute video. It'd be better to have 42-minute clips with different expert presenters. So maybe the things that are bad is when it's not diverse enough, there's not enough variety. I guess kind of goes back to this list here. Not enough examples, not enough diversity in the examples, too long of a gap between exposure and feedback, which is probably why like a long instructional video would not be as good. Or if the attribute or pattern was too subtle. Maybe if there wasn't enough detail.
I'm trying to figure out, like if we would, like one of I think our example things was like Procreate as a product. That was definitely our sign of obvious. In their training, they could certainly show you some good results. But how would they get you the feedback? Hey, draw this thing. Oh, that thing is not good. It should look like this thing. I'm just trying to figure out how you would implement such a trial and error, good example program.
It makes me think of like IKEA instruction manuals where they have like some people there and they look really happy, and then there's like some people there and the furniture is falling over and someone looks really sad. I don't know.
Yeah. All right, go ahead.
Yeah, so I think that's it. And just in summary of this section, we previously covered that experts practice better, and then this section was about experts developing deep perceptual knowledge and skills through high quantity, high quality exposure with feedback. That's really the key part there, is the high quantity, high quality exposure
Yeah.
and
So,
feedback.
and then I'm trying to, like, the exercise in my mind is like, how do we come up with, can anyone think of any kind of product? How does that, well, so Rob's asking, how does this make us build badass users? Well, we're trying to figure out how to make a badass anything at the moment. And
But yeah, I guess that's a good question, is how do you use this information
right,
in
and
your
that's
product?
what I feel is kind of the exercise. I'm going, yes, he's done, like system and social media. Feedback, arguably, so he said there needs to be feedback made. Arguably, social media gives you feedback, but it's not for good examples.
Or it's only for good, is you can only like it, you can't.
Or I'll take that back. If you want clickbait, our mechanisms work pretty good. If you want good quality writing,
No, I feel social media kind of works. I mean, like, a lot of comedians test some of their ideas, and like on social media through Twitter, they'll come up with a small quip and see how people retweet and whatnot.
mm-hmm.
And say, oh, maybe this is like something that people care. Or
well, I think it can it can work, but I'm just saying I don't think it's guaranteed to work. And it may encourage the wrong thing. If we look at all the problems of the internet today, the internet encourages all kinds of Twitter mobs. It's like,
yeah,
all the negative things of social media also are encouraged, besides the good things. Sure, having big immediate feedback is better, and it can be used correctly, but it can also encourage the wrong thing.
But let's look at a second. Like, Instagram definitely uses machine learning, right? Which is this kind of stuff,
Mm-hmm.
right? When you go on the search on Instagram, generally you get whatever like interest you have. You get pretty good content. Like, you don't even have to search for anything, and you'll get all those styles, and within those styles, each one has a stream of related things. And like, whether it's like a series of funny comics, those are usually pretty good, mainly because they all got liked and whatnot within the same pattern. So I think like the like system works. Like, yeah, it works for good and bad things, but like, it depends like what you get out of it, right? As a person, like for you as a user, if I'm a photographer and I do Instagram or to see how people react to my photos, that works.
Capture people's attention.
The goal is good. Yeah, the goal is to capture people's attention. Works very well, says Mill. As a learning tool, I can see there's a bunch of type of skill set that apply to this, like ear training, right? There's apps that do that very well. Same for music. Like, there's a lot of stuff that works very well with this. Smart Music is a software that I used once when I was learning saxophone. Fantastic. And part of it has to do with that you play, it gives you, like, it's a small thing that you play, a small phrase, and then it gives you your off pitch, off time, by how much, and then it gives you like a little, you can try again.
Mm-hmm.
Yeah, or you can listen to it
Yeah.
and see how bad it was. So
I would say this. I think the other part is how do you how do you give feedback in a way that doesn't depress the user? Like some guys, they get it right. It's kind of like the previous chapter. What makes an expert? There are those people who will grind through and get all the feedback until they get no negative feedback. And there are other people that do it, and after 3 wrongs, they give up. Oh God, I'm terrible. I got 3 wrongs. So some of that is the nature of, you know, the badass user is going to charge through and put his nose to the stone and get the good results. But I think, and again, this goes back to me, in teaching in general, a lot of times you're making the correction. The correction is accurate, but people get discouraged because they get somewhere. And then, you know, some people get things wrong better than
Right.
others.
I think it has to do, it's multifaceted, right? Like, right now we're talking about one small portion of this learning experience,
Mm-hmm.
right? It has to do with not just, okay, this is a parent game, but like, you know, there's gamification, you can make it better, like more enticing, all that kind of stuff. But the idea is the same, right? Video games do this very well. But how do you do it for, you know, learning how to finance or how to take care of your house? That each one has their own solution.
Mm-hmm.
So, but this is like pretty much the concept.
Yeah.
The book, the Atomic Habit, there's a chapter about this couple that they decided to do an experiment if they could, you know, try to raise 3 geniuses for 3 geniuses as something, and they decided to do and then they decided to pretty much do chess for their family.
Mm-hmm.
So they had 3 kids, and what they did is they made chess something that was as common as dolls in the household, right?
Mm-hmm.
So they put like every room had a chessboard, every room had some kind of chess related stuff, books on chess, games about chess, and all 3 daughters became chess masters, one by 14, like the youngest chess master ever, and they were like champions. But it became something just that it's not like it was a chore.
Mm-hmm.
It's something that they actually love, and the reason why is like in the second slide, you have his environment that value chess as something fun and as kind of an identity for everybody else. Recently, I was watching Phineas, an interview with Phineas, which is Billie Eilish's brother.
Oh, okay.
And they were talking about like they pretty much have like they grew up in a 3-room house, and there are 3 pianos in a 3-room house, 1 per room. Right? So they grew up with instruments in every single room, and so that they all can play all the instruments. They all can play some guitar, they all can play some drums, they all can play.
And Billie Eilish is like what, 18? How old is she? She just
I think she's
turned 18.
Yeah, she's like
maybe just turned 18.
She's already like so famous.
And the brother is a music producer, right? Like they produce, her album was produced like in his bedroom.
Yeah.
So, you know, and is it them? And another one that you can think about is Colbert. What's the guy? He won 2 Grammys. No, 2 or 3 Grammys. Is a YouTuber, guys that can sing anything.
Mm-hmm.
He has perfect pitch. He has an incredible ear where he can tell you a note if it's off by 10 cents or like 5 cents, and he can actually sing or reproduce. So he makes music that modulates in keys 10 cents at a time, right? Or 30 cents at a time. So like in 3 chords, it changes, like a half sharp into half sharp, key.
Modulates.
And it won like a few Grammy Awards. And like, again, the mother is a violinist, grandparent, like they're all musicians. It was something like it's in the house. And I think the mother is a violinist, teacher violinist in England. It was like in some philharmonica in the family.
Okay. Yeah.
And I think all of that kind of stuff is like a lot of it is pattern, exposure, and identity, and like these are the values. So like in order to like if you do like a product as you do over here, like how do you make him I'm combining now the 2 books. How do you motivate them would be to not as much as try to drive them to achieve a goal, but you kind of try to drive them to see themselves in the identity of the person that has these skills, right? So if we are like in our business, we should strive for our customers to see themselves as financial experts or as traders, more than this is how you make money. Because there's a difference in the book Atomic Habits between goal-oriented versus identity-oriented motivation. Goal-oriented, once you reach the goal, if that goal is something that is like the max, the best you can do, and like there's nothing above it, then you kind of lose the motivation, and you have nowhere to go after that. If it's identity, it's something that you just keep going.
That
Goal
fits
is very,
in with.
like,
Go ahead.
not flexible. It's more like vendor break. Like, oh, like if I don't accomplish this goal, then I'm failure, and I'm this, and I'm that.
Right.
If it's an identity, then it's a little.
It doesn't matter.
A little friendlier, and a little more flexible. Like you can take like steps towards like becoming that person.
Right.
That fits in with Kathy's higher context, right? It's like, right, it's like I'm not a camera guy, I'm a photographer, and that's more the identity. It's not like, well, I know how to use the Canon, blah blah blah. So no, you're a photographer. You take pictures. You do, it's like, so that's kind of the identity. I'm a musician, not just a blues lick player, kind of thing. All right, cool.
Right. Cool.
So let's go. Next section is, what was that? Perceptual exposure. Next section is, how about Alex? Glad to have you back.
Yeah.
The next one.
I guess I will do the next section.
The next one is I keep scrolling until I find the page. Perceptual exposure, blah, 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 whatever the next one is. I was just looking at it before the meeting and I can't remember what it's supposed to do. Here you go. It is, I guess there's a what experts do section.
I guess there's also a summary section right after this one.
And then help move them forward. So there's a what experts do section. That's kind of the summary. Start with that one. If you feel that's short enough, you could let me sound a little bit. Help them move forward is the next one.
Yeah, remove blocks.
That's even before that. Remove block is after. All right, somewhere between what experts do and help them move forward. I'll let you adjust as appropriate. Okay, well then, thank you for coming.
So I wanted to point one more thing out, is that we got bamboozled by the author because she gave us a lot of examples with diversity in the examples, some gaps between exposure and feedback. and the pattern was not too subtle. We learned something.
All right. Cool. All right. We'll see you in
All
2
right,
weeks.
have a good one.
Thank you.
Yeah.
Somebody in this room?